So my name is Andrew Garrad. I used to run a global consultancy business called Garrad Hassan, which specialized on renewable energy. Engineering is part of what we like to call civilized society. Almost every aspect of our life is actually governed or serviced by engineering. That might be medicine or transport or communication, but particularly energy. And within energy, particularly electricity. Until maybe 10 years ago, probably most people never knew or even thought about where their electricity came from. It just happened when they turned on the switch. As a result of changing political environment and also climate change, that situation has changed really quite dramatically in the last decade or so. So we do have to ask ourselves the question, if we were to continue to rely on fossil fuels, would we want them to come from Saudi Arabia? Would we want to rely on the good offices of Mr. Putin to allow us to import gas? So there's a political element to this as well as a very strong environmental one. But most people now agree that we have to cease to burn fossil fuels. So the question in people's minds now is not, do we have to do that, but simply by what time, when? It's not if, but when. Now, if we look at electricity and we remove fossil fuels, we're left largely with nuclear or renewables. And I think this is not the right place to debate the pros and cons of nuclear, but rather to talk to you a bit about renewables. I have spent my professional life, basically the last 40 or 45 years, in renewables and primarily in wind. When I started in wind back in the late 70s, I could carry a big commercial wind turbine blade on my back. And now, the longest wind turbine blade in which I've been involved is 100 meters, sweeping an area, say, 3.5 times the size of Wembley Stadium. So in my individual professional lifetime, we've moved from renewables, or wind energy in particular, being something very much on the margins. And I was very much patronized when I first got involved in renewables by the real power players who tapped me on the head and said, well, when you grow up, you will realize that you can only make electricity by burning coal or gas or splitting the atom. Well, the progress in those 40 years, but actually really in the last 15 years, has been truly awe-inspiring, I think. We've seen those blades moving from being carried by one person to being by far the world's largest rotating machines that absolutely dwarf the A380. Now, the most glamorous statistics are the size of the turbines. But of course, perhaps rather more importantly, is the contribution that those turbines and other renewables make to our energy mix. And last year, in the UK, roughly a third of our electricity was produced by renewables. Now, 15 years ago, that figure was probably 3%. So we've moved from 3 to 33% in, let's say, 15 years. Now, it's very easy to say that, but if you then just think a little bit about what that means, it is truly extraordinary. Last year, for example, we had some days where no coal was burnt at all, whereas 10 years ago, roughly half our electricity was produced by coal. And those achievements have been partly political, so through political support, partly social, through common demand, partly commercial through people recognizing that there is a major industry and business to be formed through this, and partly technical. Now, the first three are largely facilitated by the extraordinary technical achievements. And of course, those technical achievements have been achieved by engineers. And for me, the most fascinating thing about wind energy is that it embraces every aspect, every discipline in the engineering field. To understand and make a commercial wind turbine, you need to understand the weather, you need to understand the wind. That wind is then turned into loads or forces through aerodynamics. The blades and the rest of the machine all vibrate, so you need to understand the dynamics. The control systems, which now move these massive blades through small angular deflections, are really the nerve centers now of big turbines. So control binds the whole thing together. So we have the aerodynamics, we have the dynamics, we have the weather, we have the control, before we even get to the mechanical and electrical bits. So through huge bearings, which support the axial rotation of the blades into the drivetrains, huge bearings, huge shafts, huge gearboxes into huge generators. Moving further down, we get into detailed mechanical engineering, and then into the structural and civil side, the huge towers down into the foundations. The foundations now, of course, in the old days when there were land-based turbines, were simple concrete slabs. Now, in the latest generation of offshore wind, those foundations are floating. So we have another degree of freedom. You have to understand the floating characteristics and also the wave climate. After that, through transformers, medium voltage into high voltage, through a local distribution grid and into the national grid. So everything is there, electronics, electrical, civil, structural, and all the other ones I previously mentioned. We then go beyond that because, of course, although Britain is an island in physical or geographical terms, it's not an island electrically. It's connected to the European grid. So there may not be a Brexit in electrical terms. Now, if you're an engineer, you are good, I think, at rising to the challenge. And I rather think that the experience with wind energy has demonstrated how good we are at that. However, that does not mean that engineers are free from any social obligation. Within our brains, within our computers, on our pencils, we have solutions to most of these problems, to the problems of preserving what we consider to be our civilized society. So it is actually an obligation on us as engineers to do our bit in reducing carbon, in improving the environment. We do, however, I think, have a significant problem which we do need to address quite urgently now in terms of what we do with the large composite blades at the end of their lives. So at the moment, we really don't have a good solution. Those blades aren't recyclable. Various bits of work have been done on looking at thermoplastics, where you might be able to heat up the blades and return them to their original state, but that has largely not been successful. So we're faced with quite large chunks of carbon and glass fiber, which do need to be disposed of in some way. Now, there's quite a lot of work going on that very topic, actually here in Bristol, both I think at the university, but also at the National Composite Centre. And that is an urgent question that has to be answered and is being looked at by everybody who I think is presently involved in making big wind turbines. So it's unacceptable for an industry which sets out to be very clean to have this shadow cast over it. So what should a person, an engineering graduate, do to position themselves to be part of this amazing industry? Now, I think the answer to that there are several answers to that. The first is that it would be correct to say the really big leaps have probably been made. One of the big problems which we are faced with in terms of integration, is integration. How do we integrate the turbines, these large wind farms, particularly offshore, into the mainland grids, or elsewhere into small grids in developing countries? And I think it would be true to say that energy storage is still very much the holy grail. We don't really have a good solution to energy storage. It has always seemed to me somewhat ironic that we can generate electricity by splitting the atom in a nuclear power station. And really the best way we can find of storing that energy is pumping water up a hill in a mountain in Wales. So there's a mismatch there in the levels of technology. So it's hard to predict where the entrepreneurial activity will really be. But I think in storing, in distributing, and in making new types of power purchase contracts for customers may well be the case. You can now buy, forgotten which it is, but one of the electric cars you can buy with a power purchase agreement. So you use the car. When you're not using the car and it's plugged in, you can sell your electricity to an electricity company. So that's a completely new idea of how electricity might work. One of the great fascinations for me, not just in renewables and in wind, has been the power of mathematics. My company was mostly was built really on mathematical modelling, and I'm quite a keen atheist, so I've never had a religious experience. But I feel the closest that I will ever have got to a religious experience is having taken a big physical model, a big turbine with the wind and the aerodynamics and the dynamics and the control, all the things I've told you about, and distill that into a set of differential equations, into a mathematical model, then solve those differential equations and create some physical outputs, and then to compare those with physical measurements made on big turbines and find by some miracle that they're the same. So, and of course, in every part of engineering, you can do that. You can apply the physics and the mathematics to the physical problem. And that, I think, is perhaps the primary satisfaction for me in engineering. So there are various industry organizations which often carry job advertisements. There's Renewable UK, which actually covers, used to be called the British Wind Energy Association, but then it also embraced wave and tidal energy. In there is a list of job vacancies. There's an equivalent organisation called Wind Europe, which used to be called the European Wind Energy Association, that recently has changed its name to Wind Europe. I used to be the president of the European Wind Energy Association. And again, in there are job vacancies, of course, in a broader base there. And of course, I mean, as with everything else, and I'm sure since I'm talking to a generation much younger than myself, you'll all be very familiar with how you can find all this sort of thing out on social media. But we've now grown to a size where there is quite a big organization of agencies supporting the industry, and it is expanding very quickly. And so there are a lot of openings, making a huge contribution. By far the biggest contribution to carbon reduction so far in the Western world has come through the adoption of renewables. And you have the ability to enter an industry with a very, very bright future. So although we're at 33% now, we're at less, of course, on a global basis, but it is very, very clear that in the next couple of decades, we have to, and we will, generate almost all of our electricity through renewables. Partly will be wind, partly solar, partly others. So engaging in and being involved in the renewable energy industry is a fantastic opportunity and a very rewarding opportunity for any engineer.